line of best fit. And our unit is writing equations of lines. So we're going to be writing an equation for our line of best fit. But first we have to figure out what correlations are, okay? Because you can't just figure out the line of best fit without knowing that first. So a positive correlation are points going in an upward direction. It has a positive slope. It looks like a positive line. The only thing that's different here is our linear equations are exact points that have the same slope. These are not exact in the same slope, okay? As your x and y, or x and y both increase or decrease together, okay? So as x increases, so does y. As x decreases, so does y, okay? Negative correlation are points going in a downward direction. They have a negative slope. As x increases, y decreases, and vice versa. Okay, as x decreases, y increases. No correlation are points not going in any single direction. There's no slope. X and y are not related. Okay, it's a scattered plot. They're everywhere. Okay. So this first model here, is this a positive correlation, negative correlation, or no correlation?
Negative correlation.
Negative. Okay, how about the next one? Positive, negative, or no?
No correlation.
No correlation. So that's identifying positive, negative, and no correlations. 4 of your homework questions are like this, okay? And then you might need to explain some stuff, but, okay. So a line of best fit. Or hold on, I skipped one, sorry. Predict the correlation of the following. The value of a car and the age of the car. Okay, what? Negative. Usually, when cars, as they get older, the value of the car goes down, unless it's like a special case, but that would not, those would be like outliers, not, I wouldn't change my negative correlation. Most cars, as they get older, cost less money, except for like, yeah, classic cars and things like that, okay? Yeah. Yeah, but that's a rare occasion, and those would be considered like outliers, okay? We haven't talked about those yet, and we won't talk about that until later, okay? Month of birth and GPA. No correlation. There's no. The temperature outside and the cost of cooling in your home. Positive. The hotter it is outside, the more money you're going to be spending on AC. So when you're describing a correlation, you can describe it like this. Like if the temperature increases, the cooling cost increases as well. And that would be like how you would explain it being positive, okay? Or negative, or whatever the situation is. So line of best fit. The line of best fit, the points of the data, the line that is closest to all points. Usually in the middle of the points, so half points are above and half points are below. Your line of best fit does not have to cross through any points that are given, okay? It just needs to fit the data the best, okay? And this is an approximation. This is done without a special calculator, because we have graphing calculators and we're not using those. This is just an approximation, okay? So everyone's line of best fit might be different. So everyone's equation might be different, and that's okay, okay? Because we're going to be making an estimation, okay? So on the homework, when you guys are creating your own line of best fit, and your line isn't exactly the same as the answer key, don't have a panic attack, okay? Everyone's answer might be different, okay? All right, so for example here, I have a positive slope here. I'm going to select 2 points on my graph. Okay? So the point that I'm choosing to use at like 200, that's approximately 1.85. And it's at the line, not an actual point. So 200, and that's gonna be 1.85. So this is where, if you chose a different point, yours might be slightly different. Or if you drew your line a little higher or a little lower, it might be slightly different. Okay, and then let's do 300. And at 300, my line is approximately 2.5. What? You don't look at the dots, you look at the line. Okay? Don't look at your dots, look at your line. Okay? Because the points aren't, we're writing an equation for the line of best fit, not for the points. Okay? Yes, if the point goes through the line, then you can use that point. Okay? So now I need to find my slope. So I'm going to do y2, 2.5, minus y1, 1.85, over x2, 300, minus 200, x1. So I'm going to get 0.65 over 100, so 0.0065. Okay? So again, your slope might be slightly different because you chose different points, and that's okay, as long as it's kind of near it. Okay? And you'll see what I mean in a few. So now I'm going to take one of my points and my slope and find my new b. So y, 1.85, equals m 0.0065 x 200 plus b. So 0.65 times 200 is 1.3. Subtract 1.3 from both sides. And my b equals 0.55. So now that I have my m and my b, I can write my equation. Y equals m 0.0065 x plus b 0.55. Again, your equation might be slightly different because you use different points. As long as it's similar, okay, close to, that's all that matters. Okay, let's do the next one. Okay, so here at 200, my line is approximately negative 2. Let's say that's negative 2. So 200, negative 2. And at 300, my point is approximately negative 2.65. Again, they might give you points to use too, then you will have the same answer. Okay, so I'm going to find my slope. So y2, negative 2.65 minus y1, negative, negative, so that's going to become positive. And then I'm going to do 300 minus 200. So I'm going to get negative 0.65 over 100, or negative 0.0065. Okay, yes?
Why did you do 203?
Just there where my line's at. Start, and it's just the next point. You could have used any of them. Again, but sometimes they give you points, sometimes you have to pick your points. Everyone's points will be different, so everyone's line might be slightly different. So now that I have slope, I need to find my new b. So I'm just going to use my first one here because it has nice numbers. So negative 2 equals negative 0.0065 times 200 plus b. So I have negative 1.3 plus b equals negative 2. I'm going to add 1.3 to both sides, and I'm going to get negative 0.7 equals b. So now that I have m and b, I can write my equation y equals mx plus b. So y equals m negative 0.0065 x minus 0.7 b. So again, everyone's points might be slightly different, so everyone's equation might be slightly different, but as long as the slope is negative and it's near that number, that's what matters, okay? Alright, so finding the line of best fit. So first you need to draw the scatter plot of the dot. So you're going to plot the points, okay? Then you're going to sketch a line that appears to follow most closely to the pattern of the given point. So it needs to be in the middle. So again, it may not cross through any of the exact points, okay? It needs to have like an even amount above and below, okay? And again, everyone's line might be slightly different, so everyone's answer might be slightly different. Because if you look here, it says choose 2 points on the line and estimate their coordinates. So the coordinates that I estimate may not be the same coordinates that you estimate, okay? They do not have to be points from the original data set. The only reason why you'd ever pick a point from the original data set is if it actually crosses through your line, okay? Then find the equation of the line through those points. Okay, so here it says find the line of best fit for the following data, then predict the cost of tuition in 2008. So I already drew this data. My only thing is here, I should change this to 4 and 5 because I'm going to start here with my points at 0, 1, 2, 3, 4, 5, 6. So if I chose, if you look here, I plot my points and then I drew my line. The only point that it technically goes through is this point right here. This one is very, very close, but slightly above. So at 2004, if you see there, it's 5,126. Because it's slightly below, my line's slightly below, I did 5,125 as my point, okay? You guys can just kind of slightly sketch this. You don't have to draw it in detail, okay? Because what's really important is the solving part. So now we're going to find our slope. So I'm going to use these 2 points. So y2 is 5,492 minus 5,125 over 5 minus 4. So here I'm going to get 367 over 1, which is just 367. So now I need to find my b, okay? So I'm going to use my first point here. So that's 5,125 equals m 367 times x4 plus b. So 365 times 4 is 1,468. Subtract 1,468 from both sides. And my b is going to equal 3,657 equals b. So my equation then would be, I'm going to write up here, y equals m, 367, x plus b, 3,657. Okay, so now that I have my equation, I can predict any year. So what would I put in for 2008? I put in 8 in for what? X. So I'm going to substitute 8 in for x. So y equals 367 times 8 plus 3,657. So 8 times this would be 2,936 plus and that'd be 6,593. That would just be a prediction. Wouldn't be an actual number because we wouldn't know for sure. But that would be a prediction. And you guys will see on the next slide. It's not on yours. It's on mine. I need an additional slide. So, to show you guys how, if you choose different points, how it's different, okay? Alright, so if you see up here, come on. I had a computer generated of the data that was here. And I looked at it and saw these points here. And then I did like the same thing. And you see how for my slope I got 397, which wasn't what we got beforehand. We got 367. So but it was close. That's what I'm looking for. So if you choose different points, you get different data. And then I know this is really hard to see, but this is the exact, like if you were to put this in the calculator and the graphing calculators and you were to find it, or the computer, and you were to find the actual equation of line of best fit, this says that my slope is 409.43x. Okay, so as long as it's close, that's what I'm looking for. Okay, as long as you can prove what you did, that's what I'm looking for. Okay, and then you can see here, if I substituted in 8, I got 6,630, which is similar. So again, it's just something close to. It doesn't have to be exact. Okay? So on your homework, if you don't get the exact answer on the one where you're having to draw the line of best fit, don't have a panic attack, okay? Because they're going to be slightly different. Okay? All right. So that was just to show you guys that. Then residual points. A residual point shows how much your data deviates from the line of best fit. It can access how well the line of best fit represents your data. If the line of best fit is good, there is no pattern to the points in the residual plot. All right, so basically what we're doing is you're looking at a set of data and you're looking at the line of best fit, and does it fit the information well? Okay, are there about the same numbers above and below? Okay, does it fit if it has like a shape? Does it fit that shape? So for example here, this is actually in like a U shape. Right here, there's an actual pattern. So does this line of best fit that information? No. This is not a good representation. This is not good. And there is a pattern here. You see that? That's like an actual pattern. So it is non-random pattern. How about here? Are there about the same numbers above and below? Yeah, it fits the data pretty well. So this is a good representation. And is there a pattern to the dots? No, there's no pattern. It's random.